Hello then, welcome to this challenge. That's day 25 of the Pandas library challenge. My name is Valentine and I'll be your instructor. In this challenge, we are going to be going through a set of Pandas library concepts that would be important in data analysis, and we're going to be just practicing how to work with them so that when we are working on such projects, it's a whole lot easier for us. So let's get started. The first thing that we need to do is to visit the description section of this video and click on the practice resource link. That should take you to a page that looks like what you're seeing on your screen. Then click on the link that you see here, this one over here that says sample practice workbook. You will actually need to sign up on the Afterwork platform to access this workbook, and then you can click on continue with the learning process once you have logged in, which should direct you to this particular page, and then you can click on the link, which should take you to now the notebook. That's the sample notebook. If you're an Afterwork member, you have already access to the practice notebook, so you'll be redirected to a page that gives you access to the practice notebook. And I'll be using the practice notebook for this particular workshop or for this particular learning experience, which is just similar to the sample notebook. The only difference is that in the practice notebook, you have more challenges. So yeah, so let's access the practice resource. That's the sample notebook. And then once you get here, go to File, then go to Save a Copy in Drive to save a copy of this notebook. And it should open a notebook in a new tab, and then you can use that notebook. You can close down the original one. Once you do that, so once you get to that particular point where you have your copy, the first thing that we need to do is to go to the prerequisite section and then run the code for importing the Pandas library, as I have just done. If you feel like I'm too fast, feel free to also pause the video and then do those steps that I've mentioned, or get some clarification, or rewind the video if you need to. All right, so once we have set up, or once we've imported the Pandas library, then we can get started with the first concept. So the first concept entails getting the dimensions for a data set. So I'm trying to understand the size of the data set so that you are sure about the types of techniques that would work. So in some situations, if you have gigabytes of data, then in such a situation, then you might think about using some optimization techniques when it comes to loading the data, like, chunking, etc. So let's learn how to get the dimensions of a data set. So when we have a data set in a CSV file, we can load it using the read CSV function, whether it's the data set is located on the web or locally. We can do that using the read CSV function. So this is our data set that contains customer information. To be able to get the size or the shape or the dimensions of this data set, we use the shape property. So we apply that to the DF data frame, and that usually returns a tuple. So if I open a new cell here and just run this again, dimensions. If I run this code, I should be able to get a tuple, which is a Pandas, it's a Python data structure that has these values. So 75 just means the number of records, and 10 means just the number of columns. So in this situation, what we have here is that we are able to now see that the dimensions of our data set is 75 rows and 10 columns. To access just the individual value, we can be able to use the positions of the elements within this tuple. So the first position, the first element in this tuple has the position 0. So we can do so as shown here. We reference the tuple, that's dimensions, then square brackets 0 to retrieve 75, and dimensions and square brackets 1 to retrieve columns, and we preview, or we print those number of records, rows and columns as shown. Okay, all right, pause the video and then work on the challenge. Moving on, we can select data in a data frame by its data type. So assuming that we had a data set that looks like what we are seeing here, which contains again customer data, and we want it only to work maybe with numerical data or integer data, or more specific it's a data type such as int64, float64, or even int6, float6, not int16, float16 or 8. Yeah, then we can use the select dtypes function. As you can see here, we apply it to the data frame, and then we specify the include parameter, its include parameter, to have a list of the items that will just represent the data types that we want. So here we want columns that have int64 data type and float64 data type, and that would be stored in numerical columns, and we can display that. But before we do that, we can display those data types for those columns so that you are able to see. So we can use dtypes to be able to just have an understanding of which columns we want. So here we just want customer ID as well as age, and that's what we're going to get here because we don't have any float. So customer ID and float. All right, pause the video and then work on the challenge. Moving on, we might want to determine whether there's a relationship between two variables. If we want to maybe perform what is called feature engineering, like preparing data for machine learning models. So machine learning models would be those programs that we create that learn on some historical data and then are able to make predictions about some other variables. So correlation analysis is one of those techniques that we can use to determine what to keep within a training data set. That data set that we've mentioned as historical, that we use to train a machine learning model. Some machine learning models actually need this particular process of correlation analysis done on the training data set because they tend to perform poorly if the variables within such data set are have some positive correlation. So we, in such a situation, would need to delete or leave out one or more, or even perform some other data transformation techniques. So correlation analysis, which is what we are going to perform, just entails determining whether there are relationships between variables. So here what we are going to do is just to use the previous technique that we learned for selecting the numerical variables. So we select the ones that have int64 and float64. And then we specify, we apply the core function to that output, that's the data frame that contains the numerical columns, to be able to create what is called a correlation matrix that will give us correlation values. And that's what you can see here. We have correlation values as shown. And normally what would happen is that how we interpret correlation values usually have values between -1 and +1. So it's a scale that has -1 runs through 0, then to +1. If variables have a relationship, could be positive. If they have a strong positive relationship, it means that their values are greater than 0.5. If they have a weak relationship, the values tend to be closer to 0. But if they have maybe a negative strong relationship, then the values could be less than -0.5. So here we can be able to see that these are the correlation values, and we can see that age as well as amount spent has a correlation of 0.65, which is greater than 0.5, which means that both variables are highly correlated. The same case with age as well as income, as you can see. All right, pause the video and then work on the challenge. In some other situations, we might want to perform some aggregate operations or arithmetic operations to some existing data. So assuming that we had this data set, we might want to create a new data set, we might want to create a new column, maybe that represents some variable that would be important but would be derived from the existing data. So for example, here we could have total purchases, but we might derive a new data set called a new data frame column. So a new column called total sales that would be total purchases plus 100. So that's actually what we do here. And we save the new values inside total sales. And we can also create profit margin from total sales, divide by DF total purchases to be able to calculate the profit margin. and display the output for those new columns. So here we're just using arithmetic operations or operators to be able to create those new values, those new columns, as you can see here. All right, pause the video and then work on the challenge. In some other situations, we might want to be able to look for some data or some records that contain some value that we want. So just doing such. So if you wanted to get maybe records that contain the word John for the first name, then we can be able to do the same. You can use the technique that is showcased here, where we use the contains method from contains method or contains function from the string module, and we apply it to the data frame that we want to perform the search or match. And we would want in this case to search for the substring an inside the first name column. We define case to be false because we also want to get instances of A, capital A, N, or capital AN, both of them, etc. Then we display the filter data here. All right, pause the video and then work on the challenge. All right, in some other situations, we might want to convert existing data that is date data but has been stored in the form of string. So if we have this data set that we have here and we display its data types, we will see that the date column, join date column, has the object data type, which is text data generally in Pandas. So you might want to convert that into a datetime data type. So we use the pd.toDateTime function for that, and we specify the column that we want to convert, and we replace the outcome of that with the original. We replace the original values with the outcome of that and display the data types. And we should be able to see for join date, we have the date time data type. Pause the video, then work on the challenge. Adding new columns. This is almost similar to what we have actually done. So if we wanted to create new columns, we can use existing columns, still using arithmetic operations or arithmetic operators. So if we wanted to create maybe a new column out of first name and last name, and that new column would be called full name, we would select the first name column plus, we use the addition operator, then a space that will separate the values for the first name and last name, and plus df last name as shown here, and that would be the value for full name. And then we can add a new column. So so this is just one example of how we can be able to create a new column, but we could also create another column still using the existing data, using a fairly complex operation. But this is not that complex, but this other operation allows us to just be able to create another column called age group that would be based off the values of the age column. So we would want to create values for age group, and those values would be either what has been put here as the labels, and if maybe a value of age is less than 30, say for example 28, then the value for that particular record for this age group column would be less than 30. So we actually define the bins here, and we do that using the cut method, and we specify the column that we want to use for creation of now that new column, the bins that we want to set, and the labels. These are the bins are more like boundaries for what the data would be classified as, and the labels for what would be the values of that particular age group column. And yeah, so that's generally it. As you can see at the very far end, we have age group. Pause the video and then work on the challenge. In some other cases, we might have some data that contains date information, and we might want to possibly calculate maybe some date range. So if we have maybe this particular date, registration date, and we wanted maybe to calculate maybe a registration date between maybe a certain range, or maybe wanted to calculate the date range between the registration date and also maybe the start date or end date, then we can be able to perform that particular process. But first we need to convert the column that we have here, that's the registration date, to have a date time format or the date time data type, and we do that using the toDate time function, and then we can specify the start and end date for just being able to filter for the records that exist within this particular range. So then we can decide to just filter for that, for those records based on that range that we want. So if data frame registration date is greater than or equal to start date, and the registration date is less than or equal to the end date, which again creates a date range. So for those records with the registration date in between those two cases, those two boundaries, then we're able to filter them, and we store them in filter df and display them. Okay, pause the video and then work on the challenge. In some other situations, we might be able to also use still the same concept or apply the same concept, not using here, as you can see, we used Boolean indexing. These are just two conditions that we combined using the ampersand operator or the and sign. And we can still instead use a different approach. We can still use now the query method, which would actually take in the following condition. The only thing here, it's a whole lot more efficient. So instead of redefining again date of birth, so assuming we had this data set that contains again information about customers, and we had this date of birth column, we would first of all need to convert that date of birth to have a date time data type, which we do here, and then we set our start and end date. And if we wanted to get records that have records between the start dates for date of birth, then we just first of all define the start date as shown, which is less than or equal to date of birth, which is also less than or equal to end date. So this condition over here ensures that we have that date range that we're able to use for a condition that we can be able to have our data for. So run that and you should be able to see what we have here. All right, pause the video and then work on the challenge. Lastly, when it comes to filtering for data, in some situations we might have a data frame that contains multi-level indexed series. So you might have a data frame like this one that has two indexes. So we could have gender as well as age. So we can do that. Actually, we can set that by using the set index function, and we specify gender and age as the two indexes that we want for that data frame, and then we can sort them. So just to improve performance. So if we display this, we should be able to see now we have a data frame that contains gender as well as age as indexes. If we wanted to filter for data, how do we filter for this data using the indexes? So we can use what is called hierarchical index, where we specify if we want to get records that have maybe female, gender to be female and age to be 30, we would pass that as a tuple. So we would pass the first value as the first index and the second value as the second index. And we are able to retrieve those records. So here in our case, we should be able to get the records that contain that information. So yeah, so that's it. Pause the video and then work on the challenge. All right, so we hope you're able to get a lot in terms of value from this resource. And if you actually did find some good value that you would like to see in future learning experiences, be sure to give this video a thumbs up. And if you'd again want to be informed when we post the next challenge, that's day 26, be sure to subscribe. So see you in the next challenge. If you have any questions, feel free to ask in the comment section. All the best and see you in day 26. Bye-bye.